is Stan Ashleman from Appalachian State University, and today I'll be describing an interactive Excel worksheet that is the key component to the position metric and instructional resource management tool. The utility of the worksheet is the immediate cost differential feedback provided when changes are made on any of three workload variables: the average credit hour workload by a faculty member, shown over here, the ratio of tenure track to non-tenure track across instructional levels, shown by the cells with the yellow background here, and the average class size across instructional level, shown here. Whenever one of those variables is changed, the worksheet calculates the number of tenure and non-tenure track faculty needed to deliver the student credit hours offered by that unit. And that's down here. Computes the difference from current staffing levels, and then calculates salary cost differences between the model and existing costs. So first I'm going to describe the structural components of the worksheet, and then I'll work through the 4 questions I posed in the paper. The cells are color-coded to represent different categories of data. The cells with green backgrounds are from 2 national databases. The undergraduate non-tenure track tenure mix is given by the National Study of Instructional Costs and Productivity, commonly referred to as the Delaware Study. And you see here those values at the undergraduate and also at the graduate level. The student credit hour per full-time faculty equivalent, represented here, is also from the Delaware Study, and we have values at the 25th, 50th, and 75th percentile. The other national database, and that is the Coupa-HR National Faculty Salary Survey, provides the benchmark for a new faculty salary hire at the tenure track level. And in this case, that's $58,688. And then the benchmark salary for a non-tenure track faculty member of $36,000 is from institutional practice. The other type of fixed variable is from the institution's master course file, and that shows the actual number of credit hours, total credit hours generated across levels of instruction by this department, and also gives the student credit hours broken down by tenure track and non-tenure track for this department. And then finally, we have the actual number of FTEs at the tenure track level, non-tenure track, and then total. The interactive component of the worksheet is given by the cells with the yellow background. And whenever one of these variables with the yellow background is changed, the spreadsheet automatically calculates changes in the model target, the difference between the model target and the actual, and then calculates the salary differentials based upon those changes. In this particular model, baseline model that's provided, the 18 and 24-hour workload for tenure track and non-tenure track faculty members respectively is from common institutional practice, with tenure track faculty members carrying 3 loads or 18 credit hours over the full academic year, and non-tenure track faculty members carrying a 4 load. And then I purposefully manipulated the tenure track, non-tenure track ratios and the average class size to closely resemble the Delaware benchmarks at the undergraduate and graduate level, and also to closely resemble the 50th percentile of the Delaware benchmark for student credit hour per FTE. And you can see this baseline model generates a target of 551 student credit hours per FTE. So now let's see what happens when we change one of these variables and how the spreadsheet will automatically calculate FTE differences and corresponding salary differentials. The first example I gave in the paper was a hypothetical question of increasing the average class size at the freshman level by 5 students. So that's the 1,000 level at Appalachian State. So I'm going to click on this cell and change that value to 33, an increase of 5. So I do that, click off of it, and automatically the calculation is made showing a savings of approximately 4 FTEs, the corresponding salary reduction, and then we estimate the, in this case, FTE reduction as 4, rounding down 4.32 to 4. So I'll change that back. I'm going to do each one of these in isolation, although obviously they could be tested in combination as well. The second question posed was, what if we have the same increase, that is 5 students on average, at the senior level, and that's at the 4,000 level. So we'll click on 15, change that to 20, click off, and you can see the effect there is negligible. No reduction in the number of FTE required, and a very small change to the overall projected salary need. So I'll change that back to the original value of 15. The fourth question posed was, what if we change the tenure track, non-tenure track mix, with non-tenure track faculty members costing less? This is a national trend of having an increased instructional load by non-tenure track faculty members. So what if we change the non-tenure track course load, overall course load, to 75%, and then of course we change the tenure track to 25%. And again, we see the effect is a little, not quite as substantial as increasing the freshman class size, but nonetheless saving an estimated FTE of 2 with considerable salary savings. And I'll change those back to their original values. And then finally, the last question is, what if we increase the workload of tenure track faculty members? And I pose the question as, what if we had 1/3 of the tenure track faculty members go on a 4-3 load? And if you do that arithmetic with this number of campus FTEs, the average workload then becomes 19 for the entire department, and we can see that we have a small savings of 1 FTE with about $55,000 in salary. And I'll change that back. So the, again, utility of this tool is that you can test a variety of hypotheses in just a few minutes to see what the impact is on the total instructional FTE requirement, and then the corresponding salary changes, either increases or decreases. What we've done at Appalachian then is take these individual departmental values, aggregate them across a school and the university level, so we can see what the overall effect is on the faculty needed to cover the student credit hours that we're generating, and then what salary savings or salary increases would be needed to meet the models that are being generated.